I would like to invite Ranjini and Chandika to the stage. Please give a very warm welcome to them.
Thank you, Ash, for a big introduction. Hi, everyone. Good morning. Yeah, actually, it's going to be afternoon, I think. Okay. So we all are back from the keynote session. So while Abhishek Viramala spoke about different things on observability, started with monitoring, and then started with self-healing systems, right? So we are here. The next room, we're talking about the self-healing session. So this is how you self-heal your Kubernetes cluster. So think about it like someone working for you in your absence, right? So it feels really good for us, right? So in that case, if somebody is solving the problem for you, what you have been doing for some time now is really a great thing. And so before we start the session, I just wanted to know, like, how many of you are on call this weekend? Okay, so mostly this session is for you. So how many of your workloads are running on EKS cluster, basically Kubernetes? Okay. Yeah, so 80% of most of their company is running their products on their EKS clusters, so basically on the AWS. So with that introduction, so let's talk about the topic which we are going to, what we have built, myself and Chandika. So what if your Kubernetes cluster fixes itself even before you know something went wrong? That's great, right? So that's what we have built today, and that's what we are going to demo as well. So we have Prometheus running on the Kubernetes cluster. So Prometheus is going to detect an anomaly. So once the anomaly is detected, we have Amazon Bedrock Agent Core, which is going to do the remediation. So once the remediation happens, it will be notified in the Slack channel. So here there is no human in the loop, and it's just an autonomous incident response tool which we have built. And this is event driven, so the cost is also taken care. So we already have the introduction. So myself, Ranjini, along with me, my friend Chandika will also be presenting.
Thanks, Ranjini. So yeah, myself Chandika. So I am currently working at Autodesk as a principal DevOps engineer. So I'm very excited to be here, sharing the stage with Ranjini. So our topic today is on event-driven AI agents for autonomous Kubernetes monitoring, powered by Amazon Bedrock Agent Core. So Ranjini will be continuing the basic components which is involving in our architecture. Over to you, Ranjini.
Thank you, Chandika. So before we start with this session, right? So we wanted to talk about the most exciting headlines, right? AI agents replacing humans. So we have created a self-healing Kubernetes cluster. So people who are on the L1 operations should not start cursing me and Chandika. They are losing out the jobs. So we have bought this headlines here. So I would say, like, AI agents don't replace human, they actually reflect human intelligence. So with that being said, so think of it like someone received a alert at 3 a.m. So he got paged out at 3 a.m. And most of the alerts are auto-resolvable, but he is paged out, so he wakes up and he has to fix the alert. So it is the same autonomous thing which he's been doing for some time now. So someone in your team has debugged it, has worked on it, and he has given the logic to the agent. So that's what we have done. So we have given the logic what the human does to the AI agents. So I would say, like, start leveraging AI agents so that we don't worry about AI agent replacing humans. So with this mindset, so let's start with today's session. So why we have built this? So basically we need to understand when we are bringing in any product or solution. So we wanted to know why we have built this product. So the problem is you have hundreds of alerts every night. Mostly it would be an auto-resolvable. So 80% are auto-resolvable. You keep getting it. So that's what Abhishek Viramala also bought in about the observability metrics. So you have lot of metrics, you have lot of logs, you have lot of traces, but you wanted to know which are the ones which you wanted to address. So this is a problem what we have. Most of the company's revenue is directly tied up to the mean time to resolve. So the response time for your product is directly based on your revenue. So what happens is, so for example, you have out of memory killed pod. So you wake up, you log in, you check for the logs, you check for the events, you describe the pod. So the time taken for you to fix the event, create a Jira and post it in the Slack for visibility, it takes around 15 to 45 minutes. So what if you have someone else doing this for you? So, and there is lot of toil overhead. Means there are a lot of issues which can be resolved on its own. In spite of all these three problems, we have lot of context loss. So once you wake up, the pod would have restarted, the new pod would have come up, and the logs of your previous pod is already gone. So you don't even have the context to resolve the issue, or you don't even know what exactly has happened, right? So we are here to solve this problem. So the solution is we have built an AI agent that investigates and fixes. So this is a zero human intervention required here. So what happens? You have Prometheus, which is running on your EKS cluster. For instance, you take one scenario, you have out of memory pod which is running, or you have a crash loop back. So this Prometheus, with the help of the rules whatever we have created, so it triggers an agent. This agent actually triggers the Bedrock agent core, which in turn investigates. So any agent is powerful only when it is integrated with the tool set, right? So we also have integrated this with the tool set so that it can log into your EKS cluster, can check the things what you have been doing manually. And then it will remediate and it notifies you with exactly what is the issue it has occurred, what is the action it has taken. So this is a system architecture what we have. So on my right hand side, I have EKS cluster. On my left hand side, I have Amazon Bedrock Agent Core runtime. So on the EKS cluster, you have a demo application. So to just simulate the out of memory or the crash loop back, or you don't find the secrets, or the image not available. So we have a demo application for that. We have Prometheus running, and we also have Alert Manager. So what happens here is Prometheus scrapes the metrics every 30 seconds. So this is coming from your monitoring stack. So means most of us have already worked on Prometheus. So on the Prometheus, we have Prometheus. Sorry, on the EKS, we have Prometheus, which is scraping the metrics for every 30 seconds, which in turn sends the alert to the alert manager. So what happens is the alert manager sends the triggers the webhook agent. So when it is triggering the webhook agent gets a payload. So the payload nothing but the context of the issue, that is with the namespace and with the pod and the reason as well. So the webhook agent is nothing but it's a fast API built using Python. This in turn triggers the Bedrock agent core runtime. So like I said, we have multiple tool sets listed on my right hand side, which is the list pods, describe pods, patch memory, rollout, and create Jira and Slack. So we have integrated this with Jira and Slack for just a notification in case if you're using any other messaging tool. You can also integrate with that messaging tool. A slight bit of logic changes on the Bedrock agent core runtime. So when we're discussing on the code changes on the GitHub, you can understand that what changes you really require if you're integrating with any other messaging. So we have multiple components for this to get working. So we have alert rules, like I said. So when Prometheus has to detect an alert. So once Prometheus detects the alert, for example, I have taken the out of memory kill or a crash loop back, or when your memory usage is more than 90%. So in that case, what happens is the alert rules is sent to the webhook agent. On my right hand side, what you're seeing, the alert manager routing config, is what the webhook agent receives. So it will receive the end, basically the alert manager sends it to the webhook endpoint, and with the severity and also like the payload. The payload is the most important here, the namespace, the pod, and the reason for the alert. This is the first component of the stack, and the second component is the webhook agent. So the webhook agent is built using a fast API, and it is very powerful as it is tied up with the tools whatever we have provided. And we also have the prompts which is displayed in the Bedrock agent core. So with that, I just wanted to take you to the So if anybody wants to try this demo, we'll be sharing this GitHub link. Feel free to try. So the cost for trying this demo once would be like around $5 to $8 because we are leveraging Bedrock Agent Core from AWS. And in turn, we are also using Amazon Bedrock, and we are using a model called as Claude Sonnet IQ. Coming to the GitHub code, so we have agent code. Within agent code, we have all the logics for the agent to be running, the role for the agent so that it triggers some commands on the EKS cluster to check the issue. The app which I talk about, the app are nothing but for simulation purpose. We have created some app which has to have low memory so that we'll be able to simulate these scenarios. On the infra side, we have EKS cluster running, and we have Bedrock Agent Core. On the monitoring, we have Prometheus, we have Alert Manager. The webhook server, like I already discussed, it is a Python fast API. It is a one which is receiving the payload from the alert manager. Reason why we have chosen Bedrock Agent Core runtime is it is a fully managed AWS serverless service. So we don't need to operate the infrastructure. It is managed by AWS only. So how to say? So an SRE or DevOps engineer, no matter what, whenever there is an alert, they have to show up on the call. So likewise, our agent also should be there online to handle the task. So that's why we have hosted the AI agent onto Agent Core runtime. And another reason is this is IAM native. So we have not exposed any credentials onto our agent. So by this way, the agent is communicating, interacting with the external systems like EKS or other services through IAM trust policies. And then at the center, we have the Strands agent, which is our agent code. So we have written the agent code in Strands SDK. In Strands SDK, like a human, when they are involved in investigating a problem, they need their brain for reasoning, and they need certain tools like Kubernetes, kubectl commands for investigating the problem. Likewise, for the agents, we need to give the brain as LLM model. So here we are using Bedrock Claude Sonnet IQ model, and we are also giving some tools for the agent to investigate. So like the real engineer use kubectl command, the agent is going to use certain tools for detecting, investigating, and remediating the issues. And then another one feature of agent code runtime is it is stateless. So every alert is being treated independently. So no matter what, if you get 10 alerts, that will be scaled automatically by Bedrock Agent Core runtime. And then you have the observability provided by AWS only. So how the agent
have done the reasoning and have come to the decision and how it fixed the issue. Everything, auditability, is available in AWS console itself. Yeah. So, like I said, for every human, tools are required for investigating a problem. Likewise, we are giving 8 set of tools for our agent, for our use case. So, as per your, like, if at all you implement this project in your enterprise, you can just get the list of recurring events which are coming frequently. So those for those events, what kind of tools you need to integrate? Just writing a Python code. That's it, Python function. So here I can group these tools into 3 sets. One is investigating phase. So if at all an alert is received by the agent, so the agent, just like a human, so a pod crashed. So what a human will do, he will go and check the pod logs. He will get the Kubernetes events. He will check the pod specification, what memory it has, all the specifications, and then he will get the logs of the pod, container runtime, which is running within the pod. So using these 4 tools, AI agent also will investigate the problem. Then, after investigation, it has to remediate the problem. So for remediation, we are using two tools. One is patching memory, patching the deployment. One is rolling out, the second is rolling out the deployment. So in case of patching the memory, so if you take out of memory kill the problem. So out of memory kill the problem happens when the memory of the pod exceeds the limit which is given to the pod. So in that case, we have to patch the memory, increase the memory of the deployment. So using this tool, the agent will increase the memory with a cap of 1 GB. It will not increase more than 1 GB. So that's a guardrail we have given to the agent, not to increase more than 1 GB. In that case, it will escalate. Then it will do a restart, rolling out. Without any downtime, whatever configuration it has applied to the deployment manifest, it will be restarting the deployment. So this comes under the remediation phase. So not every problem is fixable by AI agent. So if you take problems like crash loop backoff or image pullback, so in these cases, when the image is not available, AI won't be knowing which is the correct image. And also if an ENB or secret is missing, then the agent won't be knowing which is the value of the secret or ENB. In that case, we have the escalation tools. We have given these escalation tools for the AI agent so that it will create a Jira ticket and a Slack notification with whatever the investigation it has done so far. Yeah. So this is the architecture we have come up with for this solution. So on the left-hand side, you can see the e-case cluster where the application is running. So in the default namespace, we are going to intentionally deploy some pods which will be crashing with out of memory code or something. We will show the demo how the agent is resolving the out of memory kill the problem. And we have the monitoring namespace. This is usual, every organization has it. So we have installed Kubernetes stack in the monitoring namespace. We have Prometheus and Alert Manager enabled for this demo. And then we have a third namespace called Alert Manager namespace where the webhook server is deployed. So this webhook server, the need for this webhook server is to enable the event-driven architecture. So when there is an alert triggered by Alert Manager, somebody should receive the alert and invoke the agent. So that's why we have kept a webhook agent. It is written in Fast API. So the two works of webhook agent is it should receive the alert on a API, which is on a post URL, which is /API/investigate. So Alert Manager will post the alert onto this webhook endpoint, and the webhook server will invoke Bedrock Agent Code Runtime, where the agent is living, where the agent is deployed. So on the right-hand side, you can see Bedrock Agent Code Runtime. So Agent Code Runtime, it is like, as I said, it is a fully managed serverless service. You can deploy your agent onto agent code via 2 ways. So you can either give your artifact as a zip file. So it will create a VM and it will deploy your agent onto the VM. Or otherwise, you can wrap everything as a container image and then you give the container image via ECR. So it will pull the ECR and run the agent as a container. So today we have used, we are running the agent as a container because we faced like some latency issues during the dependency installation, runtime initialization. So our agent, the purpose of our agent is to react quickly. So that's why we have wrapped our agent code as a container and we have pushed that into ECR. So when it comes to agent, we have given the agent one LLM model and certain tools as I explained in the previous slide. So the LLM model which we are using is on Bedrock, Amazon Bedrock. The model name is Cloud 3.5 Haiku. And the tools as I will explain, we have certain Kubernetes tools and we have certain escalation tools. In future, if you want, you can also add other tools like PagerDuty, Datadog, etc. Yeah. So let's see a demo with the out of memory filled problem. So we are going to intentionally deploy a pod with 32 MB memory limit, and we are going to crash the pod with more memory usage. So what happens is, so we have a Prometheus rule which will look for this error, won't kill error. So if the error matches, Prometheus rule sends an alert to the alert manager. So in the alert manager, we should have the receiver config. So that alert will be sent as email or as Slack message or posting to a webhook endpoint. So we are utilizing the third point. We are sending that to the webhook endpoint, which is /API/investigate. So this webhook server is also running inside EKS cluster only. You can host the webhook server in Lambda also or EC2 machine also. It's up to you. Just for the cost perspective, we have deployed that in the EKS cluster since we already have a EKS cluster for this demo. So yeah, so once the alert manager sends the alert to the webhook server, so the webhook server will receive three information. One is the pod which is crashing, pod name, and the namespace in which it is deployed, and the crash reason. So with these three payloads, webhook server will invoke the agent. So with this three information, agent will make use of the tools we have given to this agent. What tools? The four tools I told for the investigation purpose. It will list the pod, it will get the logs, it will describe the pod for the specifications, and it will get the events of the pod from the Kubernetes cluster. So with these informations, the agent, yeah. So with this information, so the agent will be able to come to a conclusion that what it can do to fix the issue. So in this case, for out of memory filled problem, we have instructed the agent via system prompt that it can double the memory until a limit called like 1 GB or 2 GB. So it will try to increase the memory it will double the memory and it will restart the deployment. So by this time, the deployment should have been fixed to the problem and it will send the Jira request. Let's see a demo how it works. Okay, so for now, I am just deploying a pod with the missing secret. So this will result in crash loopback problem, right? So technically, the agent won't be knowing what is the correct secret. So what it will do, it cannot do anything. So we have told the agent that create a Jira ticket with the investigation, whatever you have done, and create a Slack notification also with the Jira ticket whichever you have created. So you can see the agent runtime is being invoked with the ARN, and then So right now the response you are seeing is some other pod within the cube system namespace is having some problem. That's why it has mentioned the namespace is cube system. Let's see for our secret missing pod what the agent is doing. So actually, like this, the mirroring is not working perfectly. So we have the recording how this works. We'll play it now. Deploying a test crash.yaml manifest. So this will create a pod with crash feedback of problem. You can see when getting the list of pods. You will see how the agent respond to this. Yeah, you can see crash loopback of problem and out of memory kill problem. So by this time, the alert manager would have received the alert and it should post to the alert, the webhook server. Webhook server received the alert status firing and it invoked the agent core runtime. And so within few minutes we will get the reason as why this pod has, the response from the agent that it has to apply a restart for the crash. So it restarted and it has created a Jira ticket. Yeah, so it has applied the memory. Now you can see the crashing pod is in running state. So you can see the crashing pod is in running state right now. So the agent received the alert and it ran through the iterations of just investigating the issue, and it is auto fixable. Then it can fix it. You can see the memory right now is 256 MB. So it has doubled the memory and it has fixed the problem. So likewise, you can find out the repetitive problems which you're getting frequently, and you can add tools to your agent. So the agent would be having the right tool to apply the fix automatically. So here I have deployed the image and non-existing image. So obviously it should error. The status is error image pull or image pull back off. So in that case, so the agent won't be knowing what is the correct image. So it will be obviously creating a ticket and sending Slack notification. So in future, we have plans to integrate CI/CD also with this system. So what happens is, if the image is not existing, then it can run the CI/CD flow and it can create a new image with a proper tag, and it can create a PR with the right image, and the system will self-heal itself. Okay, so we are running out of time, so thank you for joining us today. So we would love to hear the feedbacks and questions.